Hello everyone and welcome to Applied Engineering channel. In this video we are going to do validation and optimization with vapor compression cycle model accounting for the refrigerant, thermodynamic and transport properties with our focus on low GWP refrigerant for air conditioning. In the last video what we did, we used R134A as a baseline refrigerant. R134A, as you know, is a low pressure refrigerant. So what we did in that video, we used R134A as our baseline refrigerant. We validated our simulation with the experimental data, and then we optimized and simulated it for other low GWP refrigerants like R513A and R1234YF, and you saw that the results were quite similar to the experimental results. So in this video what we are going to do, we are going to move ahead, and now we are going for our 410A, which is a high pressure refrigerant. So in this video what we will do, we will use our 410A as our baseline refrigerant, and we will validate our simulation with the experimental data of our 410A. And after the successful validation with the experimental results, what we are going to do, we are going to optimize or do simulation with other high pressure refrigerants like R32, R452B and R454B, which are other low GWP replacements of R410A. So in this video we will see how we can do validation of our simulations with the experimental data and how we can get some real results. So one important thing I would like to point out here, that if you want to do simulation or optimization and you don't have any experimental result data or you don't have any experimental setup, so it is no problem. What you can see here, it is provided all the experimental data regarding cycle DHX. It is provided. If you are working on some low pressure refrigerants like R134A, you will just have to input the baseline data for R134A and you can do your simulation and optimization, and you will get excellent results which are quite well and quite real. And if you want to do some simulation and optimization for high pressure refrigerants like R410A, so you will use R410A as your baseline refrigerant, and you will validate your simulation with the experimental data provided with R410A, and you can do your optimization and simulation with other high pressure refrigerants. Another important thing about this is that you can see, like, if you want to compare the low pressure refrigerants, your baseline is R134A, and it will provide very good results if the refrigerants which you are going to simulate and optimize are similar to the baseline refrigerant. So if you are going to simulate and optimize for low pressure refrigerants, make sure you are going to use a baseline refrigerant similar to that refrigerants which is our 134A. And if you are going to do simulation and optimization for high pressure refrigerants, then make sure that your baseline refrigerant is also a high pressure refrigerant like R410A, because the results will be very similar if your baseline is similar to your simulation and optimization refrigerants. Now let's move on and see the data provided by this research article. So here you can see that the cycle DHX reference case inputs and output data is provided to you. It has made your work very simpler. What you have to do, you have to input this basic data or reference case data of low pressure refrigerant like R134A or high pressure refrigerant like R410A into the simulation software. And what you have to do, you have to run it and you will get the outputs as given here, and you have to just check that the outputs are resembling these output values, and hence your model will be validated. So what they have done for you, for making it more easier for your use, they have already provided you the model input data which is equivalent to the experimental input data. So what you have to do, you will just input this data into your model and you will validate it. Once it is validated, you can use it for low pressure refrigerant or for high pressure refrigerant. So in this video, what we are going to do, we are going to do validation for high pressure refrigerants like R410 for a single stage refrigeration cycle, vapor compression cycle without liquid line suction line heat exchanger. So let's move on and input this data and make our model validated for further optimization. So let's go on our software, which is Cycle DHX. So for that you have to open Cycle DHX version 2.0 and you have to make a new file. So your refrigerant is a predefined blend. You will go for R410A, and then in the cycle option you will select single stage cycle, which does not include liquid line and suction line heat exchanger. Then you will move on to the cycle specification, and in the cycle specification you will select this check for reference parameters. And now what you have to do, you have to input all the input data here. So now I will input that data here and I will validate it. Now after putting all this data provided in this article, we will run it into the impose mode. So here you can see it has run into the impose mode and has provided all the results. Now what we will do, we will now simulate it. Now we will run it into the simulate mode. You can see it has also generated the reference heat exchanger parameters and the reference parameters in the impose run. So now it has provided us the simulated results. Here you can see it has provided us the simulated results with the system cooling capacity 3.63 as we have provided it. It has provided us the thermodynamic state points and other things like compressor and system results and heat exchanger results. So now what we will do, we will just going to compare the two important values, that is the COP of cooling with the cooling capacity. So here you can see it has the cooling capacity as we have provided it 3.630, and at this cooling capacity it is giving us the COP of cooling 4.438. So here we can see that in R410A basic run, when we have put these input parameters, and you can see the COP is 4.44. So this is the similar value as we are getting here 4.44 when we will round it off with the cooling capacity of 3.60. So this is how you can validate your model. And if you want to assure other things, you will find all these things are matching with the simulation results. You can also match these results in the results summary, and you can see this is the test number given. This test number is 873 run in this experimental setup. So this is how we can validate our simulation model with this experimental data. So now once we have validated our simulation model with the high pressure refrigerant R410, what we can do, we can change these temperatures, we can change the superheat or subcooling, and we can change the cooling capacity, or we can change the efficiency of the compressor, and we can play with it and we can get some real results. Also, to stay on that research article, we can compare different high pressure refrigerants with R410. So when we started, we studied like R410A has some low GWP replacement. So let's move on and check the COP and cooling capacity values of this low GWP refrigerant, and let's make a list for our own use. So for the comparison of these refrigerant, I will just make one list, and here what we will do, we will add the name of the refrigerant, we will add the COP values, and we will add their cooling capacity values. In our case, you know that the cooling capacity will remain similar, so we can just see how varying the refrigerant changes the COP values of this refrigerant. And our first refrigerant is R410A. So what we have to do now, we have to compare this with another refrigerant, which is R32, which is a low GWP replacement of R410A. So for that, we will go to the refrigerant, we will go for single compound fluid, and we will find out R32. So here we can find R32, we will just select it, and then we will come back to cycle simulation. And in the cycle simulation, we will also check the sign of yes in the optimized number of circuits, so that the simulation will optimize the number of circuits accordingly to enhance the mass flow rate and enhance the COP of the system accordingly. And then we will run the simulation again. So here you can see the results for R32. We will just compare two important things, that is COP in accordance with the similar cooling capacity. Here you can see the cooling capacity is fixed, and here you can see the COP of cooling is 4.945. We will just copy this result and we paste it into our Excel sheet, and we'll write the name of R32. So here we can see it has the same cooling capacity, and here we have updated its COP value. So let's move on and let's see which is the next refrigerant. So the next refrigerant is R452B. So let's move on and find R452B. So move back, we'll close this, we'll go to the refrigerant and predefined blends. 452B is our next refrigerant. So here is our 452B. We'll go back to cycle specification. We will not change the condition because we want to compare the refrigerants with each other. So we will just run the simulation once again. So here it has generated the results for R452B. We will just see the COP value. It is 4.889. We have entered the value of COP with the corresponding cooling capacity value. So which is our next refrigerant? Our next refrigerant is R454B. Now we will evaluate for R454B. So we will close this, we'll go with the refrigerant, predefined blend, R454B. So here is our 454B, we'll select it, go back to the cycle specification, and we will run this. So here I am just comparing the COP values, which is one of the important factor, and it usually accommodates all other things. But you can also compare the mass flow rate values, the saturation temperature values, the temperature glide values, and many other things which are present in our results. So it depends upon you, and it depends on the details you want. You can compare different refrigerant values as per your requirement. So here you can see I have summarized all the results from the simulation data, and R410 was our baseline, and then we simulated for R32, 452B and 454B, and these are the COP values, and I have plotted here these COP values, and you can see that R410, which is our baseline refrigerant, has the least COP value, and R32 has the highest COP values, whereas R452B and 454B have almost similar COP values. So this is how you can use the simulation model, and you can compare different refrigerants at different operating conditions, and these results are quite comparable with the experimental results. So that is all for this video. If you like this video, please like this video and subscribe my channel, because this is the only way for motivating me for making more such videos. Thank you very much.